The MultiComp Z80 came up relatively easy. The little differences here are that when you start up it asks for cold or warm start, and if you hit C it does a cold start, and it comes up and displays as Microsoft 1978 Basic. I believe it's the same as NASCOM 4.7 Basic, and it says 4.7B up there, and it comes up with 16K, a little bit over 16,000 bytes, which I think is a little more than the other two basics came up with. I did run into some problems when I tried to make my buzzer work, and I'm going to describe those in this video as well as what I did to fix them. The basic that's running on the card is the NASCOM 4.7 from the NASCOM 2 microcomputer, and there's a document or manual on the web for how to program that in BASIC. I spent quite a bit of time fumbling around trying to get the buzzer to work, which is on a port, until I remembered that there's a difference between the 6502 and 6809 dialects of BASIC. Everything is memory mapped on a 6502 or a 6809, but on the Z80 there's an I/O pin, and that I/O pin drives with a different command in BASIC. So if you want to access an I/O port, you either use in or out, and it has the same basic format and style as the peek and pokes do. It just accesses the I/O space. Once I remembered that, things started working better all of a sudden. The NASCOM Basic manual has kind of a more professional look than the Ohio Scientific stuff did, although I think the Ohio Scientific stuff was definitely nice. This looks more like what you would have seen in a professional document back in the day. Maybe the Ohio Scientific was more oriented towards consumers, and this would be a little tough for somebody who's a consumer perhaps. The buzzer is implemented here just like it is on the other cards, except the chip select here uses an I/O space write and I/O space read, but it uses the same latch and counter scheme as well as the same 4 select bits that come out of the register out of the output latch. The real beauty of this design is pretty much you just drop in a new processor, add a few or change a few chip selects, and you're up and running in a completely different and to me somewhat foreign environment. Especially foreign because of the I/O being a different space. One of the complications of debugging is that there's no extra pins left on the FPGA. That everything that, or the I/O connector, everything on that I/O connector goes to the video. So what I did when I was trying to debug was to take over the video R0 and the video G0, and if that line moves while the video is going, I couldn't even see anything on the screen. It's such a small part of the whole picture of the color, and even if it upset it a little bit, it didn't bother me. So I put the I/O requests and the write strobes and all that in there, and never saw the I/O requests go, so that was a clue to me that it was doing something different. But I saw the address get decoded, so I knew the address decoder itself was correct. It was just that I wasn't using the input and output or in and out, and of course after I was done I just changed those bits back to 0, and again no effect on the screen really anyway. Easy to hook those up to an external debugging method. I hooked it up to my little oscilloscope that I have here and put them on each of the 2 channels, so I was able to move across chip selects and strobes and read-write signals and that sort of thing. Probably a good way to debug with this card, so you're not completely out of luck. You can do debugging with scopes and things for when you're really stuck, and it really doesn't mess up the video because it's just such an insignificant part of the whole bit stream, or the whole bits for the characters of the things on the screen. One of the nice things about the NASCOM Basic is it doesn't require uppercase letters. It works just the same with upper or lowercase letters. Let's go ahead and run that same program that we used to make the buzzer go on the other example and see how it sounds here on the Z80. And we're set at 300 baud, of course. Oh, that didn't work. Wonder what happened. Oh, looks like I repeated the same mistake. I still have poke code in there. Let's make that an out. Make that an out. All right, let's fix the other two. And let's see how that works. Hopefully that'll work. Yep, looks like it works perfectly well. And here's the other sound program. Let's see how that sounds. Hopefully it'll be pretty good. Put the mic down there. Yeah, that's pretty annoying. Just what I want to do. Seems like it's running a little bit slower here on the NASCOM Basic. The delay loop seems like it's taking longer. Haven't timed it yet to see if it's any different. I'm pretty sure I've got this running at 25 megahertz at the moment. Yeah, that's real annoying. Definitely works though. Just as long as you don't use pokes and you use outs, things are good. Okay, let's try reading the switches on the card. Oh, have some typo. What did I do wrong? Okay, let's try reading from the keyboard and see, or reading from the buttons on the card and see if that works. 7, which is no buttons pressed. 3, 5, and 6. Looks as if the buttons are working pretty good. I can stop it with Control-C. The keyword for that is INP, not IN, but INP, like input, and the same address. And for whatever reason, it has to be in parentheses when it's a peak or it's an input. But when you do a poke or an output, it doesn't. So I don't know, never quite understood that part of it, but I guess one's calling a function. I would think out calls a function with 2 parameters instead of 1. You'd think they would both have parentheses or not. But hey, that's the way it is. And of course the hello world that runs on any computer runs on here just fine too. Whoa, what did I do there? Still has a piece of the old code in there. Must be jumping back. It is. There's 2 ways to kill it. Kill the whole program, load it again, or could just get rid of line 30. And let's see what that did. Yep, it got rid of 30, and if we run it, it just prints it once, just like it should. Trap the young players, as Dave Jones would say. Here's a fancy little program that's kind of fun to run. It really impressed everybody back in the day. It's going to print a sine wave. And I guess it's slow here because I'm running at a slow baud rate. I should crank up the baud rate and we'll see how much better it is at 115 too. I think I'm going to stop this. Let's see how well it does at 115 too. Yeah, that's a little bit quicker. Heck, I could watch that all day. Okay, so where are we at? Well, since the last video yesterday, the Z80 is now running at 80 by 25 VGA with 16K of RAM, talking to it over the USB serial, and the switching between the ports is also working. When you press F1, it switches between the ports. When you press F2, it slows the baud rate from 115-200 down to 300 baud. Of course, the PS2 keyboard works. It's running at 25 megahertz. The buttons and LEDs all work, and the buzzer is now working. I put up a video. It's working across all of the setups, and that's a pretty good set of features for a card. Still have to play with perhaps the A to D serial E squared prom, IR interface, and an SD RAM. That would be probably one to get the biggest bang for the buck. The buzzer, it might be interesting to put a PWM function in there and try to make some better sound and waveforms out of it. But the fact that it's working is fairly basic, and that's a good step forward in the whole process here. So the common thread with all of these computers is that they run BASIC. And if you lived at that point, you probably understand why, but you might ask the question, why today? Why did everything run BASIC? Here's an interesting interview with Bill Hurd and Leonard Tramiel, Jack Tramiel's son from Commodore fame.
So back in the mid-70s, do you ever feel old when you say things like that? Yeah. So back in the mid-70s, I remember, standing around talking to people in the computer industry, talking about what people would use these things for. The only reason anyone would buy one of these, or the primary reason, would be to learn to program. Because as we know, that's what everyone wants to do with computers. That turned out to be incorrect. Every pundit in the computer industry got that wrong almost every time. What people would wind up using computers for. The only person that ever made a prediction that came close to true was actually Nolan Bushnell. I was talking to him would have been about 87, and he said people are going to use computers on networks for social things, and in order to make that happen, we have to get women involved. He said girls. And you need to make it friendly enough that you can use it, and people are just going to do social stuff. He didn't say it would be, social networking, because the term didn't exist yet. But that was the closest thing to a correct prediction ever made. Yeah.
Couldn't have put it better. Thanks for watching, and good luck retro computing. Have fun. If you want more information, you can see our wiki pages for these products, and we have YouTube videos on them as well. We have a store in Tindie where we sell all of our cards. Thanks for watching our video, and if you enjoyed it, don't forget to like, share, and subscribe.